Hello friends, my name is Sunil Vinkam and welcome to Sunny TechXplore. Today I am going to show you an experiment with a AI text to speech library that is called Suno AI's Bark library. So let me share my screen. Yeah, this is that one. So github.com suno-ai and bark. So you can check that. I'll give the link in the description. So here if you see, it's a open source text to speech plus model. Okay, and it actually can add some kind of a background music or laughing experience or some kind of an emotional experience like that. It can add actually according to the documentation. So you can check this github link, which I will keep it, but for the sake of saving time, let us directly get into installation. So actually we can install it in laptop. So actually I installed. So if you see, these models are 4.4 GB here, and then almost 5 GB data is there, and depends on the internet. It will take some time, and also when you generate it will take some time because mine is not the GPU machine. So that's why I am going to do the same steps again in the Google Colab. So if you don't know how to open Google Colab, just type Colab in Google, then you will get the first links there. So you can just use it with your normal Gmail login. So once you log in, you can create a new file. So I created a file here, bark demo IP YNB. So it's a Jupyter notebook. So what we will do, we will follow these installation instructions and try. So we'll create a code block. Let us copy this. So when you are running any Python or pip command in Google Colab, you need to add a exclamation before. Let us click this. That's okay. So once you open, it will initialize the environment connection and all those things. So yeah, now it is initializing Python 3. Now it is connected, and we have a minimum GPU available. So it is now downloading the Git there. And once that is done, let us also install. What they are saying is this bark is available in the transformers library, that is Hugging Face transformers library, and we need to have these dependencies. Let us copy this and let this step be completed. Ideally Google servers should download quickly. If it takes more time, I'll pause the video and then continue. Yeah, now it got downloaded everything. I increased the font so that you could see. So we first installed the bark git repository. We cloned the git repository here. So see, okay, now what we need to do, we need to install from git the transformers library. One more code block here. Again we will give an exclamation here because we wanted to run the pip command here. Again I am pausing so that we could save some time, and again I'll continue once the library is installed. Yeah, now this also got installed. Now we have both you know, the transformers and the bark installed. And now what we need to do, we need they told the sample program, and let us copy that program from there and create one more code block here. Yeah, so here this is the auto processor from pre-trained Suno bark. So for Suno hyphen sorry slash bark, with this they already have the pre-processing components for this model, and this processor will pre-process the text that we provide so that it could be used by this model to generate the voice. And this is the voice preset here. So we are using English speaker type 6, and this is our text here. uh, yeah, my dog is anyway, that's okay, that I just copied from there. Right now let us run this. So here you can see the execution log that is happening here. Yeah, so now if you see here, tokenizer config JSON, speaker embeddings, vocab text, tokenizer, special tokens, config, so whatever. And now the PyTorch model is being downloaded. So it's 4.49 GB size. So yeah, it is getting downloaded faster. I am not pausing the video. Yeah, we'll wait. Okay, ideally now it should generate the audio and it should show us. We'll see. Okay, so to listen to this, I think we need to add this particular thing. So we'll do one thing. We'll also copy from this and paste here. Okay, audio array. Where is this audio array? This is our audio array. So after the audio array created, let us add these things so that and we can also save them as wave files that we will see. I think it is doing a lot many things here. I'll check if it is taking more time. I'll pause it so that we could save time. Anyway, I'll pause and we'll run again with audio. Previous run would not have the audio. Let us pause. Finally the program executed. It took 6 minutes. It's too much. Anyway, we have free GPU resources, right? T4 instance, so it will have 12 GB RAM, and the disk is also there, and the GPU is free GPU. That is why it is little slow, but free, right? So it's okay. Now we changed the program to add our audio also, right? So let us run it again. Hopefully this time it should take less time, but we'll see. It seems it will take again the same 6 minutes, but here if we see the RAM trend here, it a little bit spiked up here. there is no activity on the GPU. That means whatever that is happening is only using, right? So obviously when a model is actually created and when it is used, there is no GPU part here. Then let me pause it so that once the program is compiled and the audio is ready to be heard, then I'll unpause. Yeah, now the generation is over and it took 4 minutes. Yeah, 2 minutes less than previous thing, and also we have the audio. Let's hear how it is. I'll keep that. Oh, that's nice. How you can hear it. I'll keep that downloaded and keep it in a link so that you can see how it got generated. Let us download it. Yeah, I downloaded this .wav file and I'll keep it in the link. It's nicely actually spoke. And now here there are some hardware related recommendations that by Bark. So they say on enterprise GPUs and PyTorch nightly, Bark can generate audio roughly near real time. But here on our free Colab, we couldn't do that near real time, and maybe sometime later we'll check if we get a good GPU, maybe in some friend's machine or somewhere. And I don't have a GPU machine, that's the problem. Otherwise we could have tried that, and then we'll see how it comes nicely. The full version of Bark requires around 12 GB of VRAM to hold everything on GPU at the same time. So 8 GB VRAM. So even if you have RTX 4060 with 8 GB, you can only run maybe small models. That we need to check. Maybe we'll find some friends who can sponsor their not sponsor rent their laptops with GPUs to try these things. Okay, I think there is a model playground. We'll check out is the cost here. I think we need to I'll do it later, so you can just check this one. I'll keep this in the link. And now ideally where we will use it. So obviously this text to speech can be used in multiple places. At least for my use case, I have a website where I keep daily devotions. So I write there daily devotion for Christian edifying content there. So I enabled a text to speech plugin. That sounds very robotic, like I added a plugin, and here when I click it will speak, but it's not like human thing. So now if I could make it faster, I can use this content and I can generate the nice audio and keep it to provide a feel good and with that emotional touch text to speech. So that is one my use case. And maybe for training purposes you have slides, and when you can generate text from voice from this text, it will be very nice. For that what we can do is Bark generally it will take too much time to generate from a larger text, and also they don't recommend larger text. Instead what we can do is, maybe for example we have a file here, smaller paragraphs we can write, and whatever script that we wanted to generate, this can be fed to our program like this. So once all the process, I hope you are able to see this. Otherwise I'll keep these programs available in a GitHub page and update in the description. So here you can read the paragraphs, okay, and then use each paragraph, and finally you can concatenate all the audios and make it a final audio, right? In this way you can generate audio for your text to speech. So I'll try, and I'll keep this program also available, so that you can hear how this came. So here, hello tech enthusiasts. So the same thing I will try, and I'll keep it for you to refer. Yeah, that's all. Today we just tried quickly an AI tool that is converting text to speech. It also has multiple languages and all these things that you can try. Maybe in other videos we'll try some more things, with maybe adding some emotions, and creating a kind of a dubbing for a scene kind of a thing. We'll try till we meet in our next video. Bye bye. Happy coding.